Hey everybody, this is Larry. This is me going over best time to buy and sell stock for daily problem for October 18th. Let me know what you think about this problem. Hit the like button, hit the subscribe button, join me on Discord. And for this problem, I initially thought dynamic programming, and apparently maybe it works, but that's a little bit tricky because n is up to 10 to the fourth. That's going to be 10,000, which is way too much for DP if DP is n times k, where k is 10 to the ninth. Of course, k could be bound by n over 2 because you can only make n over 2 max transactions, so it's still n squared, but that's still going to be too much. Well, that's what I thought. Some people say that in the forums that you could get it right, so I don't know. Let me know if you got it right on the DP. But the way that I did it is through this thing called rallies and peaks. I actually recently solved the code force problem that is similar, or maybe I don't think I solved it actually, but I recently saw a code force problem that's something similar, so I was able to kind of figure that part out quickly. But the idea is that you always want to buy in a greedy kind of way. You always want to buy at a rally, because let's say you have these stock prices. Actually, I'm just gonna copy and paste. Let's say you have these stock prices, right? When do you want to buy it, right? Let's put in a few more numbers. Well, it doesn't make sense to buy at 8 because you could buy it cheaper the next day at 5. It doesn't make sense to buy at 5 because you buy it cheaper at 3 and so forth, all the way up to 2, because then now you know that you can always sell it for profit. So you always want to buy at a rally being the low point, and you always want to buy you always want to sell at a peak, peak being the high point, because similar idea, but in the opposite is that let's say you have a increasing sequence and you hold the stocks. Well, should I sell it at 5? Then says no, you sell it the next day, you get at 7. Should you sell it the next day? No. You could sell it the next day at 9, so forth, right? So now you have these rallies and peaks. And then the idea is that, you have these segments, if you want to call them or whatever, where, okay, let's say you have, these pairings next to each other, and you're trying to compress them into one mega segment, right? And I think that's the way that I would think about it, and there are a couple of cases you can compress them, which is kind of the way that I would think about it. But the key observation is that, for example, let's say you have this sequence, you have 1, 5, 2, and 6. You can actually, in a way, mentally compress them into one by swapping the rallies, right? And why does this work? Well, this works because if like the difference between 1 to 5 plus the difference to 2 to 6 is the same distance from 1 to 6 to 2 to 5. So then now, in a way, you merge these distance to, now you have one big segment of 1 to 6 with the profit equal to 8, right? And now that you have that, you could kind of separate those two. Now you have one bigger segment and two segments that you could take independently, right? Because now this is 5, and then now you have 2 to 5 for 3. And the key point here is that, for these problems, you always think about the invariant. And what is an invariant? An invariant is something that as you do something to a problem, it doesn't change. And in this case, it allows us to do greedy solutions, because now instead of having, this is a profit of 4 and this is a profit of 4. Now we have a profit of 5 and a profit of 3, and then now we are able to sort it in a way such that we always want to take the 6 first, and then if we can do a second segment, we'll do 2 to 5, right? Which is the same as, if you do one segment, then this is equivalent, right? Because you do 1 to the 6, which is one segment. But if you get to have 2 segments, then you could kind of break it down to 1 to the 6 and 2 to the 5. So that's one case. And then the other case is, well, let's say you have this thing. Let's say these are 2 adjacent pairs. Well, and you're trying to combine them into the same segments. Well, this segment is already inside this segment, right? So we don't have to combine anything. We could just fold this out, and then record the profit for sorting later or whatever, right? So that's basically the idea I have for this problem. Took a long time, as you could see by the video time, but I have some code, and I'll go over the code in a short while. I have some code that it filters out the dupes, adjacent dupes. It finds the peaks and valleys. It removes some peaks and valleys from the beginning so that you have this alternating order. It's too much code. I could have written it closer, so I'm not going to highlight this much. But here's a quick peek in case you want to know. And then now we keep everything tracked in the stack as the segments that we want to merge, right? So we have the rally and the peak. If the stack is empty, we just put it on the top of the stack. Here we want to, here, as we kind of know, this is basically saying that the previous rally and the previous peak is within. Maybe a better way to write this is actually going this way, with the understanding that previous peak is always previous rally. So now that you combine these segments, you know that these are already in between, so you could just append them and then pop, and then in this case we have two adjacent segments that are overlapping, and then we want to merge them and then take out the middle piece, right? So that's basically what we have here, and then we also pop. Otherwise you just have two segments that don't merge with each other, so then you could just push it on the stack. And at the very end, then we just take the length of these segments, we sort it, we reverse it, and then we take the max k of those profits after k segments. Cool. So what's the complexity here, right? So everything here is linear. So removing dupe is linear. Finding the rallies and peaks are linear. We just look at each element once or twice or whatever. So that's linear. Here we use a stack. And one thing that I would say about stack and analysis of complexity is that you only pop up each element at most once. And you only push at most once. So it's going to be O of n. This is O of n as well. So the big cost is just this sort. So it's n log n. And that's pretty much it. And the space complexity is a lot of linear space. You could go through it to see that this is the case. So it's going to be linear space. So n log n algorithm, linear space, and that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and you can watch me solve this live afterwards. Hey everybody, this is Larry. This is me going over day 18 of the October Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, how you solved it, and whether you dig it or not. And I'm always trying to get better, even at explanations. But today's problem is best time to buy and sell stock for. So I've done a couple of best time to buy and sell stock problems, and I think they were dynamic programming. Let's see. You may do at least K, or at most K's transactions. K could be really big. So that's not bad. N is equal to 10 to the 4th. That may be a little bit tricky, because the dynamic programming solution I had in my head was n squared. This K could be really big, but you could really ignore it because if K is bigger than n, you just set it to n, or maybe even n over 2, because you have to buy and sell, right, for the number of transaction. So K could be effectively n, right? But for n is equal to 10,000, that's a little bit big. I think one thing to notice about this problem is that you only carry about something called rallies and peaks. I actually recently solved this, not this, but a similar problem on code forces. So I'm able to kind of articulate this a little bit better. But basically, let's say you hold a stock, right? And you want to sell it at a given time. So now you have a stock, you own the stock right now. Your future prices to sell at 1, 2, let's say they're increasing, right? 2, 3, 4, 5, 6, and then decreasing. It's just decreasing. It doesn't really matter, right? In this case, it never makes sense to sell early because from 1 to 6, if you sell early, then you have to buy again, and then you already lose profit. So in this case, you compress all this stuff in between to just 6, right? And similarly, if you look at this sub matrix and you're like, well, it doesn't make sense to sell later because you could get the higher price now, right? So that's how I would do it. There may be about another one where, like, maybe, I have something like this. Let's also get rid of the rallies, and let's get rid of this. Oh, oops, I have negative one, right? And you're like, well, how do I deal with this, right? And the idea is just try to figure it out, and we'll talk about that part later. But yeah, so that's if you have a stock and you want to sell. That's why you want to only sell at a peak, so you can kind of compress the array a little bit. And when you want to buy a stock in a similar way, you have 5, 4, 3, 2, 1. It doesn't make sense, if the prices are going down. It doesn't make sense to buy it as it's going down, right? You want to buy when it's going at the lowest point. So this is kind of like a little bit of a greedy. So then you could compress the array this way, and I think that's what I'm going to try to do initially, and then we could kind of play around with some stuff. But yeah, let's just call it. Usually it's called peaks and rallies, but I'm just trying to figure out names. Names are tough, so let's just call them new prices equal to this. For that's n is equal to length of prices, say, for index in range of n, if so we want to put it in if it is bigger than the two adjacent numbers or smaller than the two adjacent numbers, right? So it has to be okay. So then, yeah. So if I'm just gonna break it down. Pretty straightforward. New prices. We always want to include the first price and the last price, because those are the last prices to care about. And then also if prices of index is greater than, or you could yeah, I think that should be okay. Otherwise you won't get some of the answers, right? So I think we'll do an else, because actually we should just do continue. And prices index is greater than prices of index plus 1. Then we also insert. And then the only other case is if prices of index. So we're going to do a little copy and paste because for speed purposes. If it's smaller than both its adjacent ones, we also input it, right? Oops. Then now n is equal to the length of new prices, because now we have a new array effectively. And then now we have this this rallies and peaks. Basically you have these alternating numbers, right? Like 1, 5, and then smaller, higher, but smaller, higher, right? And then the question is, how do we kind of combine them in a good way, right? Well, the question is, I think one thing to notice for this problem is that like 1 to the 4. I think a tricky problem is just trying to figure out like I'll change the numbers a little bit, but whether 5 minus 1 equals 4 or 6 minus 1, right? That's the decisions that which is 5. So we take greedy, we'll take the 5, but then we could have made double the profits by 5 to 1 and then plus 6 minus 2, right? For 2 transactions, right? So for 1 transaction you may do 1 to 10, this one to the later 10, but for 2 transactions you might not, because you may do 1 6 and then 1 to the 10, right? So there are definitely a couple of things here to consider, and I think so for problems like this, what I try to do is look for something called an invariant on the problem, and from that invariant, we try to figure out like we do something, and the invariant still true after we do something, right? And that's the basis for some greedy type algorithms, and that's probably what I'm going to try to think about right now. But yeah, but I think that is actually the idea that we have, which is that we have to figure out the pairs such that you know, we have to figure out how to kind of compress them in a good way. Because in this case, we have to, I think there's two things, right? One is just figuring out how many compression pairs do we need, because we could make one as I am trying to do this live, so apologies. Definitely watch it on higher speed if you like, but So now that we have these valleys and peaks, we can we can kind of mash them up together, right? Is that right? I think for now, what I want to do is just do a case analysis, right? So we have these cases. We have two valleys for now and two peaks. I think so. So the way that I would think about it is that, let's say we have this case, right? And you have to choose between either, you have one transaction, you do 1 to 6, which is equal to profit of 5, or two transaction, you do 1 to 5 and then plus 2 to 6, which is 4 plus 4, which is 8, right? So that part is obvious, but I think the way that I would write about it is that we can actually reorder this whenever we see this pattern. We can actually reorder it so that it's plus 2 to 5, right? Because if we kind of reorder the paired 2s, then this is the same answer. And what does this do for us, right? What this does for us is that given each pair of valleys and peaks, we can do the swap. So then essentially what you're doing is, you swap the 1 and the 2, right? So now you have these two pairs instead. And the reason why we want to do the swap, because they're mathematically equal, and you could kind of do the math on that to kind of list out the cases. They're mathematically equal, which means that now you can use the greedy algorithm on it, because now you want to do the most greedy thing, which is what you wanted to do in the first place, which is that from 1 to 6 is what you do, and then you do a transaction inside as actually it wasn't like this, it was this, right? Sorry. Right, so that this is actually an equivalent is kind of going back in time and then getting that extra profit from the 2 and the 5 as well, which is kind of really crazy if you think about it. It's almost like time traveling. But in any case, so this is basically, let's just say, yeah, you have no, let's just say you have value of 0. Yeah, let's say you have a path from value to 0 to peak of 0. V sub 1 to peak of 1. Then and this case comes up if the peaks and the values are over each other, right? Because if this is smaller, then you wouldn't want to do it anyway. Or like it makes no difference for you to swap them, because then 0.6 is the more greedy one, and you could still prove that they're equivalent, but it just doesn't do anything. Actually, are they equivalent? I mean, if you do transactions, they're equivalent, but if you do one transaction, then it is not equivalent. In this case, the beauty is that that if we have this case, right, we book it down to like, okay, if you do transaction, you have to do this thing. If you do one transaction, you have to do this thing, which is like a weird overlapping thing. And we break into 2 transactions such that now that we have 1.6, 2 to the 5, then these transactions can act independent of each other, and then the invariant holds for the for us to kind of do something greedy. Okay. So I think now let's also do we want to start at a peak. Oh, sorry, we want to start at a valley because you don't want to sell at a peak. So we can check that really quickly. If new prices of 0 is greater than new prices of 1, then the first element is a peak. So then let's just we just remove the first element in an easy way, and also check that new prices is greater than 0 first, or greater than, or equal to 2, I suppose. Similarly, let's massage the data for the rally, because we don't want to end in a rally. It doesn't really make sense, right? So the last element is smaller than the last element 2, then new prices is equal to new prices, right? So now based off this, we can go through the pairs one by one and kind of go with it for index in range of 0 to n in a pairs of 2s. So rally, sub rally. How do I want to do it? So now we're looking at adjacent pairs, but now we can even do better, I think. So what that probably we looked at, which is that, oops. Why did I erase that? Okay, yeah. So this thing we look at, right? To formalize it more, if v sub 0, let's say we have pairs v sub 0, p sub 0, and p sub 1, p sub 1, v sub 1, p sub 1, we can swap them to this case if in this case v sub 1 is greater than or equal to, maybe, but I guess if it's equal to, then you don't get any benefit from swap, so let's just make it 2. And p sub 1 is greater than p sub 0, right? So let's do that, and because of a sort of a greedy way, we can actually keep on doing that, because in this case v is only going to get bigger. When you keep on swapping, v1 will stay big and p sub 1 will get smaller, but should be okay. Yeah. And then now basically we have we're trying to do, we have all these pairs of now we have all these pairs of valleys and peaks. No, this isn't it. Right. I forget if this is inclusive or not, but this is a long video. This is a hard problem, or I don't remember it. But oh, I didn't finish writing this. Oh no, I think I did, and then I erased it by accident. Make sure everything compiles and it's okay. Oof. What am I doing here? How did that happen? Wow, I'm mixing things in my head, but that's why we run the code and make sure that it compiles. Okay, cool. Always forget if it's inclusive or not. Oh, and is equal to the length of new price. A lot of implementation issues. Okay, so at least it runs. So now we have. Now what we want to do is we want to so there will be cases where what we're trying to do is that, you know, we have all these, there are a lot of these possible pairs, and we're trying to kind of decompose them into just like pairs that cannot be further have this operation done on. It's kind of like sorting in a way, and kind of like, you know, pulling them apart so that they're all independent of each other. And then after that, we can greedily take the k most transactions. So yeah, I think this reminds me a little bit of I mean, this definitely reminds me a bit of, I'm trying to think whether it's max queue or max stack or something like that, because basically we're trying to ask a question, and that this is the fundamental step for solving kind of max queue and max stack type problems, is that, okay, this is my current state. How can I take advantage of the past, right? What am I trying to get, the max element or the min element from, or you know, or you know, going back, right? And I think it's going to be a stack, and then you just keep on popping, and then keep on pushing things together. But but yeah. This is a hard one. Give me a second to think. So basically, what we want is looking back. You know, let's say we have a rally and peak now here, right? What do we want? Well, we want to find conditions where this rally and this peak is. So we have to look back. There's no looking forward, right? So if we look back, we have to get I'm trying to also double check in my mind whether we can do it in a reasonable way. Okay, so I guess we just look back for every pair and then keep on going at it, and then we'll see what happens. I'm going to play around with this, but let's start with stack, right? So this stack will contain all the rallies and peaks from the previous that we've seen before. So let's just say stack.append rally and peak, right? Maybe. But basically, we look at the top. If length of stack is equal to 0, then we oops, what was it? I thought I had it, but up rally and peak. Else, and we can continue. Otherwise, we go to the next one, and then we kind of look at the top, right? If because then you have to kind of go. You can only go back to adjacent ones. I think that's the part that I missed. Versus a max stack would be kind of like you have to take the best of the previous ones, which maybe is a little bit not true. So now stack sub 0 is equal to previous rally, previous peak is equal to stack sub the top of the stack. So stack.pop now, and now what happens, right? So if this is the case, if previous if rally is bigger than previous rally and peak is greater than previous peak, then we do this magical thing. First okay, so if this is true, then what we want to do is store this pair because we don't use it anymore. So let's just say profits. So we put profits is equal or append as we say v1 pre-0, so that's previous peak minus rally, right? And then now we push back on top of the current or the now with the thing swapped, which is previous rally, current peak. So this only gets smaller. This obviously remains the same as we kind of go through the stack. So eventually this will get stopped, right? So yeah, else what happens? Else we just kind of do we always pop this? I guess we only pop this here. Because here then we just kind of push it back on top of previous, the rally peak, which is the current one. And that's pretty much it for this part. And then at the very end we just get all the profits. So while length of stack is greater than 0, we do profits dot append. Let's name it peak is equal to stack of -1. So we just append profits, which is the peak minus rally, right? And then now we just have to take k of them, and because we have all profits, we could sort it, right? So profits dot sort for, so we do a sum of profits. I guess it's from the end, so reverse. But now we just have to take the first k, right? So profits of to the k, maybe minute by the length of the length of the profits, so that we don't go over. And we just have to return that. And hopefully that's right. Oh, I don't pop, so this will never finish. I have to wait for it to TLE, so let's k is equal to 2 in this case. Take a quick look. Oh yeah, okay, fine. We need a lot more cases. The big one is going to be the time limit one, so I think that's what I would think about. This looks okay, so I'm fortunate. Let's just pick up some randomly big numbers just for funs. Just to see performance. Oof, wrong answer. That's unfortunate. It's a good thing I retested this, but well, it's debugging time, and that's fun. Let's try 0 transactions. See what we get as a. I wanted to test this independently anyway, but. Oh. Why do we only get 4? So maybe I messed up something somewhere along the way. Let's print profits. I might have done something weird with, because this should never have negative numbers. So let me take a quick look. Or maybe I messed up my rallies and peaks. Okay. I think my algorithm is mostly right, but sometimes this happens. So let's print out. Maybe my assumption is wrong on this being rallies and peaks. No, this. Okay, well, 6-0 is not right. 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 26032. Huh. Oh. That's fair. I think the way that I did it, I didn't care for numbers being the same. And now that's biting me a little bit. Let me think about it and do it, because I I just assumed that there'll be Is there a better way to do rallies? Let's see. Let's just do something like if prices index is equal to prices index -1, we can just continue, because in this case, is that true? Yeah, because you would catch it on the other side, so I think it'll be okay as long as you do it one side. Yeah, okay. So this looks way better in the rallies, but we still have an issue that we have to resolve, which is that for some reason, this is still giving 4, right? Sometimes implementation is hard, but this is also a long code, so but at least new prices is right. So you're also learning debugging, so you know. So now we print out profit, and again, you know, normally I would probably debug this in a debugger, but obviously I don't have it in this thing, so it's a little bit weird. But what is my new prices again? Why are there 2 and 6, 0 and 3, 2 and 4? Okay, so we're not doing some swap correctly at some point, because what we want to do is, or what we expect is that given these cases, the 0 and 3 and the 2 and 6, these should swap, right? And then this becomes 0 to 2 to 3, and then 0 to 6. But we're probably not seeing that, which is why we're having issues. Let's see. The rally is okay, let's print out the stack along the way. the real stack is the valleys and peak we've seen along the way. So 0, 3. And then the, did I, so stack with the rally peak, let's print that out. So 2 and the 6, but for some reason the 2 and the 6 should swap into 0 and the 6, but that's not happening. Is this not happening? I'm very first principles on debugging sometimes, so But yeah, so this case is true, right? So that this should go here. We put in the 3. Did I mess it up? Previous value is 0, right? So this should be, oh, I'm just dumb. I popped right after I appended. Okay. Okay. That is just a silly mistake. Let's give it a submit. Fingers crossed. Oof, one-time error. Not enough. Oh, yeah, okay. I thought that this may be a case. Yeah, okay, fine. But that's okay. That's an easy fix. 5-minute penalty, but easy fix. Less than 2, return 0. But yeah, I think one thing is that, you know, when you do these problems, you're gonna have good days and you're gonna have bad days. What the hell are you on that? And it's kind of like you have to have the mental fortitude to kind of keep grinding and keep trying and keep working hard. And sometimes even on stream where, you know, you're like, what is going on here? What is Larry doing? But, you know, sometimes you give it all and try to give it a little bit more. What is going on? So new prices is 2, but if the last element is less than the second to last element, is this not happening? Oh, oh man, I'm really. This should be after this, of course, after the filtering. Just a lot of careless mistakes, to be honest. Today in general, but oof. Okay, so at least this is a real error. Not a happy one, but still a real error. 13 instead of 14. Okay, what is our situation here? Let's take a look at the profits. It may be that there's some condition that is not held by how I handle this, but so 7, 6, 2, and 1 with 2 transactions, is it? Okay. So what would our ideal transactions be? Well, we could do it in 14, so we have to make 7 and 7, maybe something like that. So 2 to 9 and then 1 to 8 is probably the answer that we need, but we're not doing that. Why are we not doing that? Okay, let's see the stack along the way. Let's just print out the stack for now. We should stack and profits there. Now look at the states. Maybe I'm missing one condition. This one feels a little bit iffy, but that's okay. Oh no. Okay, let's get rid of some of these older cases. I usually paste them somewhere in a notepad so that I can go back and, you know, put them back in. Okay, so this is 2 and 8. 7 and 8, 7 and 9. I guess 7 and 9 is okay. I mean, I guess technically you could have compressed this as well, and then remove it from the stack, but it doesn't affect anything, I don't think. Anyway, no, it has to, because if it's Z code, then it would also eat this one. So that's what I need. Okay, that's a subtle thing, I suppose. Let's try again. I wasn't thinking about that condition, to be honest. That is a good one. And then again, now I could copy and paste back what we had before, so that I can, TDD it in a big way, except for the tester provided for us. Okay, looks good. But I've said that a few times, so let's kind of give it a go. One time out. What is going on? I keep on getting these. Did I mess up something? Well, it's good to get it out of the system now and not during a contest. So earlier today, I also had some issues with wrong answers, but and this is just all implementation, right? Because there's nothing tricky about this. It's just me being, I don't know. There's just edge cases that I'm not handling well. This is already off, but that's, what was it before? Because that should have compressed it. But so there's this. How did this happen? I need to do something smarter about it. I think I'm just not, again, this is going back to the original sin, I suppose, of duplicate numbers. I don't really handle the duplicate numbers very well. I think what I need to do, I just need to do another filter and just get rid of duplicate numbers. I've been just silly about it. Let's see. It is it is something that I'm practicing. I haven't really done this, so with respect to what I mean by this peaks and valley trick that I've learned only recently. So that's why practice makes perfect. Even sometimes you're just gonna run into issues where you don't anticipate it. Okay, that looks good. Let's TTD again by pasting my earlier things, and okay, that looks good. Let's submit it again. Oh wow. I don't know how many submissions I have been doing. Maybe you're keeping track at home. If so, please leave a comment on how many wrong answers I have, because this has been now getting sad. Okay. So my answer is just really off. And this is going to be, I was fortunate with before with the other case, but this is going to be really tricky to, let's see. Okay, so this makes it slightly easier, not easy, just easier to debug. Is that true? I don't know. Let's even just try one. One, I think maybe we'll have a good answer, but okay. And then the thing is that they do give you the right answer, so we know that 2 as well. Yeah. So now let's take I don't know, have to array and see if that'll be work. It's kind of like a bisection where like I'm just trying to get you know, trying to narrow down the cases where I'm wrong. So still wrong, so that's good. As you can see, we already removed half of the, or like a lot, not more than half, like we moved half a couple of times, so like 1/8 of our length to, and we still have the wrong answer, which is kind of good. I mean, so that, because that means that you know, that means that we're able to kind of narrow down the cases a little bit, because once that matches, then that's actually a little bit harder to debug, and because our n is now really small relatively, but that means that there's something really fundamental. I mean, probably just the way that I do this compression, to be frank, but okay, so this is right? So that means that unfortunately we have to, there's something inside the rest of this that makes it good. Okay, so this is still wrong answer. Okay, is this short enough for a twofer? Let's see, right, 194. So now we can maybe play around with, well, let's take some prefix. I think these are useless. So, probabilistically, yeah. Right, so then now let's kind of print out the stack and the profits. My back is a little sore because I've been on this problem for so long. Real issues, yo. Anyway, so okay, so we go 2 and 100, and then we I guess stack these up and add 21 as the profit. Okay, we add this 4166. We add 333, okay, and 394, which is okay. What do we want here? Probably like something. What is possible? What is this input? Alright, this 0 looks lovely. So 0 to 96 maybe, and then 2 to 100, so 98 plus 96. This is like scavenger hunt, but okay, so there's a 98 and a 96. How did we lose the 96? Oh, we have to kind of figure it out, right? So 2, so the 98 is here, so the 96 is 0 to 96, so let's kind of see that progress. Where is it? It's not, okay, so that means that this is true, but then this doesn't compress with this. So that means that there's another case going on, right? Is there a thing that we can use here? Also, we use a stack, but I think this should be a while loop at some point. Yeah, this should be a while loop, I think, maybe. And then something like that, maybe. May also run into errors because I forgot to check the size. Well, in this case, the rally and the peak will keep on being the same. That's why. So basically, we want actually the rally peak is equal to stack 1 stack that pop, something like this, and then here then we can just do this. My computer's a little slow now. What are you doing? Why is my copy and pasting not working? Really? Okay, now my computer's having issues. Are you serious? I just want to. Okay, let me just type it. Let's see if that changes anything. Oh yeah, we have to do something like at least 2 elements, so that otherwise you don't need to compress it if it's less than 2 elements. Still wrong, but let's see. So it's still another recurrence that we can figure out here, right? So the 796. So yeah, this I don't know what the number is, but 796. Can we just get rid of this? Because in this case, that means that this is going to be an individual one, right? So okay, so start pop. We say profit start append previous previous peak minus previous rally. But then can you do it to all the numbers? I don't know. Is this going to do it to all the numbers? Yeah, this is a little bit weird the way that's true, because then you just remove all the numbers all the time, right? Let's think about this for a second. I think I hand waved over one of the cases too much. Okay, let's take a quick look. So while length of stack is greater than 0, so that we can kind of merge this in there. This is true, then otherwise, I think otherwise we break. Yeah, and then maybe there's another way. Maybe I'm forgetting a case, which is, so this is just this is the merging step. What happens in this case? Oops. In this case, rally is equal to previous rally. I think I missed that. Wow, I'm like really off today. But let's see what happens here. I have to append it at some point. Rally peak. Otherwise, doesn't do anything. Well, now we don't do this yet. Okay. Okay, still wrong, consistent. So this is basically the code that we have before, except for that we changed to the while loop. So that should be a little bit better. But okay, so what do we do in this case, right? So okay, let's print it out. Or let's put it here. I think maybe I just misanalyzed the case. It seems like it. Misanalyzed a lot of case. So in this case, what do we want to do? We can probably just remove this, right? Because it's not going to contribute to this. But we only want to remove this if the this number is greater, right? Because if this is smaller, if this is 10, say, do we want to remove it? No, because because this can be compressed in the future, maybe, right? So okay, so I think that's maybe the case that I missed, maybe. Right now I know as much as you do, probably, which is to say, I don't know, or maybe you know more than I do, actually, is what I mean to say. But yeah, if rally is less than previous rally and peak is greater than previous peak, then I think we can just compress, because then this means that whatever profit that's in here, it would get factored into here, I think. Maybe previous peak minus previous rally, stack that pop. I think we don't have to change it, so I'm just thinking right now whether the order matters of these two operations. I mean, that's better, but now I'm just thinking about whether, you know, this is magic or not, right? Like, why does this? I mean, I don't know. I think it's just a little bit lucky, maybe. Like, for example, I'm just checking whether, like, there's no reason why this code should be before the other, though. Apparently, it doesn't matter and it still works. But we should probably compress this as well into one loop, because I don't think it makes sense to be separate. Here. Because there's no, I can't, from a symmetry reason, I can't understand why it will be one before the other. Okay, but okay, now I'm really not confident, but I have that TDD thing, so let's kind of run it for the cases and then see what happens if we move the print statement, because this is a lot of to print. And okay, I still forgot a print statement, but it looks okay as the answer. So let's kind of submit it again and then see how many wrong answers I get. This may be my, I was going to say, I mean, I did say, I think this is my most number of wrong submissions for a problem. But yeah, but I don't know. If you're still here with me, thanks for watching. This has been a journey. It's a tough problem, tougher than I expected, to be honest. I just expected this to be like a DP because I never seen this yet. But it has an interesting thing. I mean, I knew about the rallies and peaks, and I still had these issues. I think it's just about case analysis, and I didn't really break it down to these three cases that much. I thought that this one case is good enough. I didn't consider this as a separate case, to be honest, until, like, you know, the wrong answers kind of dig me into it, and you could kind of see how I debug the wrong answer. So maybe that's not a total loss. So what is the complexity of this? Well, this is going to be linear, right? I do a lot of linear stuff here as well, but you know, at the end I do sort it, so it's going to be n log n at least. Or this is also using only stacks, and each element only gets looked at once, so this is also linear. So this is n log n. Then there's a lot of linear space, so n log n of n space is the complexity. This has been tricky. This has been tough for me. Let me know what you think. I struggle a bit with this one, but yeah. Yeah, and I don't think my explanation was super great, but it's just analysis of, basically, to recap, the idea behind this problem is just you have these there are a couple of ideas, and it's tough because of it. You could decompose an array into these rallies and peaks. Those are the numbers that you care about, and you always want to buy at a rally, you want to sell at a peak. That far makes sense. And then after that, you want to decompose it such that you know, you have a couple of transformations. So basically, you have, if this is the case, you know, then the profit is, you go to you know, the profit of before is P0 minus V0 plus P1 minus V1, and that is actually the same as P0 minus V1 plus P1 minus V0, right? And you could kind of show, this is really obvious. But the thing is that because of the relationship of this if statement, so this takes takes two transactions. This also takes two transactions, right? So now you kind of decompose it in this way and this is only for adjacent ones. And once you kind of do that, the reason why I swap it is because in this properly, V1 is bigger than V0, and P1 is bigger than P0. So P sub 0 minus V1 is going to be bigger than P sub 1 minus V0. And from that, we basically changed the numbers around, moved the money around so that greedy works. So that's the reason why we did it. And then that's the other case is saying that, V0, V1, P1, if V1 is greater than V0, but P1 is less than P0, right? Oh, I think I just got this sign wrong. That's fine. Okay, so in this case, profit is equal to, again, the same thing, really, right? But now, you know that this swap cannot work, because in this case, this would be negative, right? Or one of these would be negative, so you cannot make this swap. So, and because you know that you cannot make the swap, you know that in the future you cannot make that swap as well because you have these dividers, right? So basically what we did is that we just remove it so that as that if we do take that transaction, we can only take that transaction by itself. You could say that is an atomic one. But yeah, that's what I have for this problem. Let me know what you think, and I will see y'all tomorrow. Bye bye.